Hello, my name is Greg Crinklaw and I'm the developer of SkyTools. In this video we're going to look at using SkyTools 4 with ACP Scheduler. So we're going to look at the basic workflow and I'm going to introduce you to some of the concepts and some of the tips and tricks along the way. So the place to start is the target selection tool, which I have selected here. And what I'm going to do is I'm going to set up an ARP Galaxy observing program. So I'm going to select the ARP Galaxy list here. Now where did I get that list? I got it from here. Get target list, browse Skyhound. I got it from right there. Now there's going to be a lot more of these eventually. We're still in testing. So now we have a list of ARP galaxies that I want to observe. The idea is to narrow it down to those that have a good image scale, are bright enough to not take hours and hours and hours and hours of exposure time in my telescope, and are basically high in the sky so we get a nice image. So there's two modes to this tool. One of them is to help you plan for a specific night, and the other one is to plan long-term throughout the year. And we're going to use the long-term planning feature since we're using ACP Scheduler. So the first thing I'm going to do is I'm going to set the attachments to ARP. Now what are attachments? Attachments are things that you attach to an object. And what I did here is I set the folder that those attachments will go into. If I open the object information, we can attach links, web links, images, notes to this particular object, and they're going to be sorted into the ARP folder. Then I'm going to set my observing program to ARP Galaxies, and that is there to organize your observing program so that later on we can narrow things down to just the ARP galaxies or just the objects in our ARP observing program. And I'm going to set the weather to auto. We've got weather selections here, but I'm going to set it to auto. Let me show you what that does. Open up my location here, click on set weather. These are the current conditions. If we go to January or February, these are the values set for that month, and they're set for each month. These are the typical values, the typical temperature at night, typical humidity, and this is the typical seeing throughout the year on a good night. So I've set this all up ahead of time, so when we use the auto weather selection, these are the values we're going to use, because if we're doing long-term planning, we don't really know what the weather's going to be on a particular night. This allows us to plan throughout the summer or the winter and use at least typical values. So what I'm going to do here is I'm going to use the long-term planning functions. I'm going to look for objects that have a signal-to-noise ratio of 30, are at least above 1.5 air mass. I'm going to enable the filters here. I'm going to set it to a limit of 20 minutes. So what this means is that in order to achieve a signal-to-noise ratio of 30, it can't take longer than 20 minutes. This is in the widest available filter, which is probably your luminance here. And the other filters are probably going to take a little longer, so I've limited this to just 20 minutes. This here relates to the maximum air mass. What I'm saying is that it must be above 1.5 air mass for at least 30 minutes. So here, these filters tell us objects that are bright enough to observe within a reasonable amount of time. This filter setting here is telling us that it's also going to be high in the sky for long enough to observe. And that has narrowed us down to 31 objects. So we can sort on various things here. We can sort on the image scale. A means it's a very good image scale for our imaging system. B, C is worse. D is pretty poor. I'm going to sort on the best night to observe throughout the year, and this has put objects that are close to my current date at the top, And the first one is the Cocoon Galaxy. It has an image scale of B, so this would probably be a pretty good target object. It subtends 316 by 78 pixels. You can see some of these are considerably smaller. So this is a good sized object. I'm going to go ahead and right click on it and create a new imaging project. I'm going to select that I'm going to set that to my ARP program. These things here, we can just basically leave them where they're at. The important one is the priority. This will be passed on to ACP Scheduler. So if you set this at a higher priority, it's going to be observed at a higher priority. Move on to the Composition and Tiles tab. Now, this telescope has an autoguider. This right here is the field of view of the guider camera. The stars marked in green are the ones in a good range for the autoguider. So what I want to do is rotate this around and drag the whole thing so that this star is within the autoguider. Our target object is still within the main frame, which is this rectangle here. So this will be saved with the imaging project, and when Scheduler goes to observe, it will observe in this configuration. Next, we go to the exposure goals and filters, and I'm going to expose for the main extent or the arms of the galaxy. I'm going to go for a signal to noise ratio of 30, which is pretty good. I'm going to select LRGB filters. Now, in order to achieve a signal to noise ratio of 30 in the luminance filter, it's going to take about 18 minutes of exposing, but in the others it's going to be close to an hour. So I'm going to customize each of those filters to use 2x binning, and that will not record as much detail, but these are for color primarily. We'll get our detail from the luminance filter. That cut them down to a reasonable amount of exposure time. So now we have some ACP specific things to set here. If you're familiar with ACP, these should all be fairly familiar to you. I'm going to set the sky conditions to fair, so it needs to be a pretty good night. I'm going to choose that the moon must be down, and we're going to dither by 2 pixels, autofocus, and do a full calibration on the images, including we're going to fix the hot pixels. So these things are all going to be passed on to Scheduler for this particular project. Right here where I selected the moon must be down, that's pretty simple and straightforward. If I didn't select that, what SkyTools would do is try to find a set of mood avoidance settings that are appropriate to your object. And I'm going to go into that in a little bit more detail here, because this value, the minimum acceptable quality, is the most important setting for using SkyTools with ACP. I'm going to talk about what that actually does. I'm going to move down here so we can see the night bar on the target selection tool. You'll see this night bar in various tools throughout SkyTools. This is the course of the night. The dark area is the dark period of the night. The red dashed line is the altitude of your target object, in this case the Cocoon Galaxy, throughout the night. The teal line is the altitude of the moon. And if you look closely, you'll see that the target object is in bright red, and then it goes to dark red, and dark red over here. That's because it fell below our obstructed horizon. When you create an observing location, you can set up an obstructed horizon. So if you have trees or things like that, it knows where they are, and SkyTools will use that. But the most important feature of the night bar here is this blue line. This blue line is the exposure quality line. And what SkyTools does is it uses everything it knows about your imaging system, your location, and the target object to compute the signal-to-noise ratio on a really good night, like this one, say right here where it's high in the sky. Remembering we chose this because it had the best night was March 27th, and this is actually set up on March 22nd. So we're very close. If it wasn't for the moon here, this would be the best night of the year. So on that night, on the best night of the year, under the best observing conditions, SkyTools calculates what the signal-to-noise ratio is. And then this blue line is the relative signal-to-noise ratio on this particular night at this particular time. So if it's way down here, it means the signal-to-noise ratio is pretty poor. And that's what you'd expect. It's fairly low in the sky. There's twilight, moon is up. But it goes up and it stays pretty high until the moon goes down, and then it gets as high as possible. So that tells us that on this night of the year, at between 1 and 2 a.m., it's as best as it's going to get. So that's what SkyTools does with its imaging quality, which is this blue line here. Now, that relates to this minimum acceptable quality selection. When this is set to A, it means that it has to be very, very high, or we're not going to observe it. If you set it to B, then we can come down a little lower on the imaging quality line, say to here, and it will still be observed. If you want an object and you don't care how high it is in the sky, how good your opportunity is, you just need to get it, you could set that to poor or none, and it will observe it clear down here or clear down here. And these parameters are passed on to Scheduler. It's what SkyTools uses primarily to set Scheduler up for your observations. So if you want just nothing but the best when it's high in the sky and well observed, then set this to excellent. The problem with excellent is it's generally going to limit you to a short period of time throughout the night. So you might want to give yourself a little bit more room to observe. You might bring that down to B. I'm going to go ahead and keep this as excellent. You can see it's high for a really long time. Excuse me. Okay, so now we've got everything set up, and I just wanted to add that if I didn't select moon must be down here, SkyTools will look at various nights and look at the configuration of the moon and figure out the moon avoidance parameters for ACP that are required to keep the moon far enough away that we can reach whatever minimum acceptable quality we have selected over here. But I'm going to go back to moon must be down and click done. Okay, so we have set up our first imaging project. And so let's pick a couple others. We've got the mice here, M60. How about ARP2? That's going to be observable later in the night or maybe later in the year. It's got a pretty good imaging scale. It's 240 pixels across. It's up for 8.3 hours on its best night. Best observed in May, but we can observe it in early April. So I'm going to go ahead and create an imaging project for it. Select ARP Galaxies. Go to Composition and Tiles here. We've got some stars we can use. Oops. Got some stars we can use. So I'm going to set it here and use this star as our guide star. Exposure goals are like before, LRGB. And I could have created a template and applied all these values. But I really think that if you want to get the most out of your observing, you probably need to set each project individually. And as you can see here, when I set this for higher picture quality, 30, exposing on the main extent, I've got some pretty long observing times here. And part of that is because I've chosen bin times 1. If I go to bin 2, it comes down. So I'm not sure I really want this object. I'm going to skip it. We're going to go on to maybe this IC galaxy. Yeah, it doesn't have a very good image scale. How about M60? We'll set up for that. Create a new imaging project. Assign that to our ARP galaxies. Composition. Well, we've got a star over here we can use as a guide star. Let's see if we can get to it. We can. It's near the edge of the field. This is our target object. But that will work. Exposure goals. We're going to go with our LRGB again. And I'm going to set it for acceptable picture quality of 20. I'm going to go ahead and put these to bin 2. And this is the main thing that using a template can help us for. It can help set this up. If we always use bin times 2, we can put this in. And similar settings to what we had before. I'm going to get rid of the moon must be down, dither by 2, autofocus, calibrate, fixed pixels. So now we have 2. And I'm just going to leave it at that for now. We're going to go on to the ACP tab. And once I select, first thing I want you to see is that this is an eye telescope and it's not set up to be used with ACP Scheduler. So it's telling us that, and it's not going to let us use it. Let me show you where that comes in to play. If we come down here to Automation and Configure, this is set to use ACP with iTelescope extensions. If we wanted to use it with Scheduler, we'd need this set to ACP Expert. And the telescope that we're using, this one, is indeed set to ACP Expert. So I'm going to go ahead and select that telescope. If you don't have a lot of telescopes, you're never going to have to deal with this stuff. Here are all the projects that I've selected, I've created for this telescope, but I'm going to select just my ARP Galaxy Observing Program. Here are the 2 I set up. Again, we're set up for a specific night, but that's just there for previewing. Let's go over some of the basic things here. If we select an object, or we select a project actually, it tells us what filters there are, how many tiles there are, what its priority is, when it's generally observable, and what observing program it's in. Well, we've already narrowed it down to ARP, so it's just going to be ARP. For this particular night, I'm going to switch it to tonight for me. For this particular night, the moon is sort of interfering. You can see it's going to be best between 3 and 5. But when I select it, notice that there's some text here. It says it's observable between 22:16 and 4:54, and that is the times where these red vertical lines are. What this is showing us is what the constraints are for ACP Scheduler. It is computed that for this night, using the constraints that it's going to pass to ACP Scheduler, it would allow it to be observed between this time and this time. And this time is here because that's when it sets behind our obstructed horizon. You see it goes to a darker red line and it dropped off very quickly. That's because it hit the obstructed horizon. So SkyTools has put all that into Scheduler. And I'm not going to go into the details of how it does that. The other thing I want to mention is the moon separation. When it calculates the moon avoidance for Scheduler, this is a minimum separation. When we do that, we're looking at the brightness of the sky as affected by moonlight. And that's going to depend on the phase, the altitude of the moon, how close it is to our target object. But a lot of telescopes have open tubes and other issues with stray light. So the brightness of the sky may not be what limits how close you can observe to the moon. And in this particular telescope, I've found that you need the moon to be at least 60 degrees away, or there's just too much light bouncing around in the telescope tube. So this will be a minimum separation for the moon avoidance algorithm. Let's look at the Cocoon Galaxy here. I've selected that. It says it's observable between 304 and 544. This was the one I said the moon had to be down for. Remember, these vertical lines here are the times that are going to be going to be used by Scheduler. We're sort of previewing what the constraints are in Scheduler. So we can see it's working pretty well for this night. It selected it from here to here. Now, I'm going to show you a shortcut. We've selected a constraint of quality of A, so it's got to be, this blue line's got to be really high. I can right-click on that and change it to B. So I've just modified my imaging project, and that will modify the observable times here. It didn't really modify it much because I had it set to where the moon had to be down. Let's try this one here. I'm going to set that to C. And now it says it's going to observe from here to here. That's pretty much most of the night. If I set that back to A, watch what happens. Now it narrows it down. Same thing can be done with the ACP sky conditions. I'm going to change that to fair. And the priority, let's move that up to high. Okay? So now we're going to go ahead and submit this to ACP. First thing we have to do is set it up. So we go here. You have to put in the server address of your telescope. And that can be an IP address as shown here, or it can be a domain name, whatever you use. This is the same information you'd put in when you logged into your telescope. This is where you're logging in, and this is your username and password word. Contact information can be filled out, and that will be passed on to Scheduler as well. Now when I click OK here, you need Scheduler running because it's going to check our login, and if it didn't work, it will say there's an error. But it did. I have Scheduler running. So I'm going to go ahead and submit a project. I'm going to click Submit. And it says that M60 was successfully submitted. I'm going to select submit the Cocoon Galaxy as well. I did M60 twice. Notice the status is S. And I'm going to start Scheduler. Oh, it's already running. So let me find it here because I want to open it up. And here it is. I'm going to look at the schedule browser. And this is what has been entered into Scheduler. We actually put M60 in here twice, so I'm just going to look at the Cocoon Galaxy. It splits the filters up into separate plans so that they can be observed separately, and each one can have their own settings. So we've got a priority of 3. If we move down to the observation here, it's recorded the position angle, the location that we selected, and it has chosen 14 60-second exposures for this blue filter. For the red filter, for the green filter, it chose 13, and for the luminance filter, it chose 19, and for the red, it chose 13. These were all to reach the signal-to-noise ratio goals that we had set. So here it is. You can then run it and in schedule as normal, and it will go out, observe it, mark it as observed, and we're not quite set up for this yet. I need Bill to do a little more work, but eventually you're going to be able to click a button here that will go out to Scheduler and get the status of all of your imaging projects, and they will appear here. Excuse me. So the purpose of them appearing here will be to follow and log their progress. So I'm going to go to the observations tab here. That's all done here. We'll be adding new observations automatically from this area on the right. Scheduler is going to provide a lot of information, which parts were actually completed, which filters, how much of each filter was completed, and that will be filled in automatically here. All you're going to do is give a general idea of what you felt the overall quality of the image was, and you'll apply that. And then as these are completed as per the exposure goals, then they will no longer show up here in your list. So you'll no longer need to schedule them because they will be complete. So that is, from one end to the other, the basic workflow. And if you have any questions, be sure to ask me. Thanks for watching.